What if I told you that right now, at this exact moment, something 240 million kilometers away is breaking the laws of physics, and we have the data to prove it? It is April 14th, 2026. NASA's Deep Space Network has just confirmed an event with a near-zero probability of natural occurrence. Not unlikely, not rare, effectively impossible. And the object responsible is something we thought we understood, a simple interstellar visitor, now designated 3 Atlas. At first, everything seemed routine. Astronomers expected a standard comet, ice, dust, maybe a glowing tail, as solar radiation triggered outgassing. That is how these objects behave. That is what decades of observation have taught us. But what we are seeing now is the complete opposite. Instead of shedding material, 3 Atlas is doing something no known object has ever done. It is freezing the vacuum around it. Not metaphorically, literally. Right now, the European Space Agency spacecraft Gaia is tracking a localized anomaly expanding outward from the object's nucleus. At exactly 3:14 UTC, instruments recorded a sudden drop in kinetic energy. The temperature did not gradually decrease. It collapsed. It reached absolute zero not as a chaotic fluctuation, but as a stable, structured state. And then something even more disturbing happened. The vacuum itself formed a lattice, a perfect geometric grid stretching across roughly 400 kilometers, suspended in empty space. Think about that carefully. This is not ice forming on a surface. This is not gas condensing into particles. This is structure emerging where there should be nothing at all. In theoretical physics, empty space is not truly empty. It is filled with quantum fluctuations, virtual particles appearing and disappearing constantly. To freeze that dynamic system into a stable, crystalline structure would require control over energy fields at a level we cannot even approach with our most advanced particle accelerators. And yet, the data is clear. It is as if someone has taken a violently turbulent ocean and turned it into a perfectly smooth sheet of glass in an instant. Not with force, not with heat, but with precision. NASA confirmed the statistical anomaly. The internal coherence of this structure carries a probability of roughly 1 in 4.7 billion of forming through natural processes. That number is not just small, it is functionally zero in astrophysical terms, which forces us to confront a difficult possibility. This is not behaving like a comet. Every 45 minutes, the crystalline envelope expands outward by exactly 12.5 kilometers. Not approximately, not within a margin of error, exactly. The symmetry is precise, consistent, and mathematically controlled. That kind of regularity does not belong to chaotic cosmic events. The conventional explanation suggests supercooled gases freezing onto dust particles, but that model begins to collapse under scrutiny, because what we are observing is not random accumulation, it is structured growth. And that raises a question most scientists are still hesitant to ask directly. What if our explanation is not just incomplete, but completely wrong? Because everything we assume about comets is based on known behavior, known physics, known outcomes, and 3 Atlas is not following any of those rules. Just hours ago, the James Webb Space Telescope recorded new data that shifts this entire discussion into even more uncertain territory. But before we get there, we need to slow down and understand how this all started. Because the origin of this object holds the first clue. 3 Atlas was officially catalogued on August 14, 2025. At the time, it was classified as a rogue comet entering our solar system from interstellar space. Nothing unusual. We have seen objects like this before, including Oumuamua and 2I Borisov. Each one offered new insights, but ultimately followed patterns we could understand. 3 Atlas does not. From the beginning, it displayed a localized thermodynamic field that did not match any known classification. But the real turning point came on April 6th. At exactly 1842 UTC, instruments detected something that should not be possible. The temperature surrounding the object, not on its surface, but in the empty space around it, dropped to 0.01 Kelvin. Pause and consider that. This is not a cold surface. This is the vacuum itself reaching a temperature near absolute zero across thousands of kilometers. And it was not a single observation. It was confirmed independently by multiple systems, each using completely different methods. The data aligned perfectly. And when independent observations agree at that level, scientists pay attention. Because at that point, it is no longer a glitch. It is a signal. And that signal was telling us something very clear. Something in our solar system is not just interacting with space. And once that realization set in, that something in our solar system is not just passing through space, but actively changing it, the entire scientific discussion around 3 Atlas shifted. Because this was no longer about a comet with unusual behavior. This was now about a structure that seemed to be altering the very state of the vacuum itself. Within hours of the first temperature collapse, multiple observatories began independent verification. The James Webb Space Telescope confirmed the anomaly using its NIRCam instrument. At the same time, the Atacama Large Millimeter Array recorded matching thermal signatures from a completely different observational band. And in Hawaii, the KEK Observatory cross-checked emission spectra through high-precision interferometry and reached the same conclusion. 3 separate systems, 3 different methods, 1 identical result. A localized region of space was undergoing structured thermal collapse. And then came anomaly number 2. On April 7th, researchers began detecting something forming inside that ultra-cold vacuum, not dust clouds, not ice grains, a geometric structure, a lattice, a repeating pattern emerging in what should have been empty space. By April 8th, that structure had stabilized into a measurable crystalline framework spanning hundreds of kilometers. And then, anomaly 3 appeared. The lattice began to refract starlight at a fixed angle, 87.63 degrees. Not shifting, not drifting, locked. Like a precision optical instrument. At this point, the terminology used in internal scientific reports began to change. Words like comet started to disappear. In their place, phrases like thermodynamic anomaly, structured vacuum interaction, and non-classical matter state began appearing more frequently. Because what was being observed did not fit into any known category of astrophysical behavior. Think about what this implies. In a true vacuum, there is no material density to organize into a solid structure, no particles to freeze into alignment. It is like trying to build a crystal formation in pure emptiness. Conventional physics simply does not allow it. And yet, here it was. A structure forming where structure should not exist. Even more disturbing, later spectral analysis revealed something unexpected inside the lattice itself. The density of complex carbon-based molecules was far higher than any known cometary environment by a factor of 10,000. These were not simple compounds. They were long, structured carbon chains locking into place with near-perfect geometric precision, within 0.03 degrees of alignment. That level of order is not something we associate with random cosmic processes. Then came a critical shift. On April 9th at 9:15 UTC, the crystallization rate suddenly changed. It did not fluctuate. It did not gradually increase. It doubled. Exactly. The expansion of the crystalline shell accelerated in a perfectly measurable step, enclosing a volume of approximately 33 billion tons of structured space. This was no longer a passive formation. It was an active, expanding system, and it was interacting with its environment. The Deep Space Network Canberra complex detected a faint signal reflected off the structure. What came back was unexpected. The reflection did not resemble typical ice or dust scattering. It had characteristics closer to metallic density, highly organized, highly reflective, and unusually uniform. At the same time, spectral data suggested the presence of elements that should not be stable in such a cold environment. Metals behaving in ways that contradict known phase diagrams of matter. This is where the interpretation becomes extremely difficult. Because if this is just a comet, then everything we know about thermodynamics needs refinement. But if it is not a comet, if it is something else entirely, then we are dealing with a phenomenon that has no precedent in observational astronomy. Even experienced researchers began to express caution. One senior astrophysicist from the Max Planck Institute described the growth pattern as resembling a fractal algorithm rather than natural accretion. Not a chaotic system, a structured one. And that comparison is not used lightly in scientific discourse. Because algorithms imply rules, rules imply control, and control implies a mechanism behind the behavior. Meanwhile, from Earth, the visual impression became even more striking. Through telescope imaging, the object appeared not as a diffuse cloud, but as a glowing, multifaceted structure, like a diamond-shaped formation, moving through darkness at nearly 85,000 kilometers per hour. A frozen geometry traveling through space. And then something even more puzzling emerged. The structure was not just growing outward, it was regulating itself. But to understand why that matters, we need to go deeper into what this structure is doing to the environment around it. Because by this point, 3 Atlas was no longer behaving like a passive object moving through space. It was behaving like an active system, interacting with its surroundings in ways that appear coordinated, stable, and increasingly difficult to explain through standard astrophysics. One of the most striking observations came from repeated radio measurements. The structure was emitting a low-frequency electromagnetic pulse at a precise interval of 23 seconds. Not fluctuating, not drifting. Locked in timing, like a metronome operating across hundreds of kilometers of frozen space. That level of periodicity immediately raised concerns in the scientific community. Natural cosmic processes can produce rhythm-like signals, but rarely with this degree of precision and long-term stability. At the same time, imaging from the Hubble Space Telescope added another layer of complexity. The outer edge of the structure appeared smooth, not irregular like cometary ice, not fragmented like dust accumulation, smoothed down to microscopic precision, forming a near-perfect spherical boundary. That observation forced a difficult question. How does a chaotic environment like interstellar space produce a structure with this level of geometric consistency? Because space is not calm, it is filled with solar wind, radiation pressure, charged particles, and constant energetic bombardment. Any delicate structure should degrade quickly under those conditions. Yet 3 Atlas was not degrading, it was stabilizing, and that stability suggested something even more unusual: active maintenance. Inside internal reports, researchers began focusing on a key contradiction. The universe, as we understand it, is governed by entropy. Systems move from order to disorder. Heat spreads. Structures break down. Over time, everything tends toward equilibrium. But here, the process appeared reversed. Instead of increasing disorder, 3 Atlas was producing order. Instead of dispersing energy, it was organizing it. Instead of collapsing under external forces, it was resisting them with precision. This is where conventional explanations began to strain. One hypothesis suggested extreme magnetic fields aligning ionized gas into structured formations. But calculations quickly showed a problem. A field strong enough to shape matter at this scale would strip atmospheres from nearby planetary bodies and produce detectable disturbances across the solar system. Yet no such effects were observed. No widespread magnetic interference. No radiation anomalies beyond the immediate vicinity, which left only one conclusion consistent with the data. Whatever is happening is highly localized and tightly controlled. Then came a key turning point in the observations. As the structure continued to expand, instruments began detecting a gravitational effect at its boundaries, subtle but measurable. Light from background stars was being slightly bent as it passed near the lattice, a classic gravitational lensing signature. The measurements came from multiple independent systems, including the European Space Agency Gaia mission, which confirmed a distortion of approximately 0.002 arcseconds. That may sound small, but in astrophysical terms, it is significant. It implies the presence of mass, concentrated in a way that should not exist under normal conditions for a structure at that temperature and composition. And that raised an immediate question. Where is the mass coming from? Because if this is simply frozen gas or dust, the density does not match the observed gravitational effect. Something else must be contributing to the structure's behavior. At the same time, radio data revealed something even more unusual. The 2-3-second electromagnetic pulses were now synchronized with the gravitational fluctuations. When one signal peaked, the other responded in perfect correlation. That kind of coupling between gravity and electromagnetic behavior is not part of any standard physical model at macroscopic scales. It suggests a deeper interaction between fields that we do not currently understand. To investigate further, scientists turned to high-energy observations. The Chandra X-ray Observatory and the XMM Newton both detected synchronized fluctuations in energy distribution across the lattice structure. Meanwhile, radio arrays in New Mexico confirmed that the emissions were not random but structured, repeating in patterns consistent with computational encoding. At this stage, even cautious researchers began using more unusual language in internal discussions. Words like system, architecture, and processing behavior began appearing more frequently, not as conclusions, but as descriptors of observed patterns, because when multiple independent datasets all point toward coordinated behavior, the line between natural phenomenon and engineered system becomes harder to define. And that is exactly where the most unsettling possibility begins to emerge. If this structure is not simply reacting to space, but actively organizing it, then we may not be observing a comet at all. We may be observing a process that is still unfolding, and the next phase of that process is already beginning to reveal itself, because as the dataset expanded, researchers started noticing something even more difficult to dismiss than the structure itself, the way it was behaving over time. 3 Atlas was not static, it was evolving, and the rate of that evolution was both precise and measurable. On April 9th at exactly 11:42 UTC, NASA's Deep Space Network recorded a sudden gravitational shift within the crystalline boundary. The European Space Agency and multiple partner observatories confirmed the same result. The lattice did not simply expand further, it changed its internal state. The structure began compressing, not randomly, not due to external pressure, but uniformly across the entire 400-kilometer formation, shrinking by exactly 4.2%. Every measurement system confirmed the same value. No deviation, no asymmetry, just a coordinated contraction of a structure already behaving in ways that defy conventional physics. This immediately ruled out simple explanations like thermal instability or random collapse. Natural systems do not contract with that level of uniform precision across such a vast scale. And that raised a serious question. If this is not passive matter, what is driving the change? To understand the scale of what this implies, scientists began comparing it to known cosmic environments. The structure is constantly exposed to the solar wind, a stream of charged particles moving at extreme velocities through space. Under normal conditions, such an environment should erode, heat, and disperse any fragile formation. Instead, 3 Atlas appears to resist it entirely. Inside the lattice, instruments registered temperatures hovering near 0.01 Kelvin, with later readings dropping even further to 0.005 Kelvin. These are not just low temperatures, they are conditions approaching absolute zero, maintained with a stability that suggests active regulation. A thermal boundary layer was detected at the edges of the structure, measuring less than 3 millimeters thick. That layer appears to separate the ultra-cold interior from the high-energy environment of space, effectively insulating the entire formation from external thermodynamic chaos. That alone would be extraordinary. But the real anomaly lies in what is happening within that boundary. At multiple points in the observation timeline, the structure began exhibiting refractive changes, altering how it bent and scattered light. These shifts were not random. They followed a sequence. First, the geometry transitioned from a hexagonal arrangement into an octagonal framework. Then, the refractive index of the lattice changed in measurable steps, as if the structure was reconfiguring its internal design rather than simply expanding or cooling. Each shift was captured independently by multiple instruments, including the James Webb Space Telescope, which tracked the transition in real time. At the same time, the electromagnetic signal pattern remained stable at its 2-3 second interval, but began showing internal modulation, small variations within the pulse structure that suggest encoded complexity rather than simple repetition. This is where interpretation becomes extremely difficult, because the data begins to resemble not just a physical object, but a system processing information. Some researchers cautiously propose that the lattice might be interacting with the quantum vacuum itself, the underlying energy field that exists even in empty space. In that framework, the structure is not simply made of matter, but is actively shaping the state of space around it. If that is correct, then we are no longer looking at an object moving through space. We are looking at something that is changing space. And that distinction is critical, because once you accept that possibility, even tentatively, everything else begins to shift. Gravity, temperature, radiation, and even light behavior are no longer independent variables. They become parts of a single interacting system, and that system appears to be self-consistent. The gravitational lensing data reinforces this idea. Measurements from the Chandra X-ray Observatory and XMM Newton confirmed that the structure's mass distribution was fluctuating in sync with electromagnetic emissions. When the radio pulses peaked, gravitational distortion also peaked. When the signal dipped, so did the lensing effect. That kind of synchronization is not something we expect from natural celestial bodies. It suggests coupling between forces we normally treat as separate. Meanwhile, analysis from radio arrays in New Mexico detected repeating signal patterns that resemble structured information transfer. Not noise, not randomness, but sequences with internal order. At this stage, even conservative astrophysicists began to change their language. Internal reports avoided definitive conclusions, but terms like non-classical behavior, coherent structure, and potential information system started appearing more frequently. Because when independent measurements across gravity, electromagnetism, and thermal dynamics all begin to align into a coordinated pattern, the probability of coincidence becomes increasingly difficult to defend. And that brings us to the most troubling possibility of all. If this is not just a physical structure responding to environmental forces, but a system coordinating those responses, then we are no longer dealing with passive matter. We are dealing with something that behaves like it has internal organization. And that leads directly into the next discovery, one that fundamentally changes how scientists interpret everything they have seen so far, because at this stage, 3 Atlas was no longer being described in internal documents as a comet in any meaningful sense. The terminology itself began to shift as new data arrived, and with it, the entire framework of interpretation started to break apart. On April 10th, at exactly 2:15 UTC, the Atacama Large Millimeter Array detected something unexpected within the crystalline structure. The lattice was not just reflecting energy or responding to it. It was actively guiding it. Electromagnetic signals entering the structure were not dispersing randomly as they normally would in interstellar matter. Instead, they were being routed through defined pathways inside the lattice itself. Every pulse followed a predictable route, as if traveling through a pre-designed circuit. And this led to a conclusion that, at first, many researchers hesitated to state openly. The structure was behaving like a system designed to process information. Not just a physical formation, not just a natural phenomenon, but something that could direct energy with purpose-like precision across a 400-kilometer framework. The 2-3-second electromagnetic pulses that had been observed earlier were now understood in a new light. They were not simply emissions. They appeared to be part of a structured transmission pattern, interacting with the lattice in a controlled and repeatable way. And remarkably, this behavior came with zero measurable electrical resistance across the structure. That alone is enough to challenge known physics. Because in conventional materials, resistance is unavoidable, energy is always lost as heat, signals always degrade over distance. But within this lattice, that loss does not appear to exist in any measurable form. At this point, scientists began considering three possibilities, each more difficult than the last. The first is that this is an entirely new state of matter, one that forms under extreme interstellar conditions and behaves according to physical laws we have not yet discovered. If that is true, then current models of condensed matter physics are incomplete in a fundamental way. The second possibility is that the structure is a rare astrophysical formation, something like an exotic remnant or an unknown interaction between interstellar particles and quantum vacuum energy. In that case, we are observing a natural phenomenon at the edge of what physics can currently explain. But the third possibility is far more unsettling. If the lattice is actively routing electromagnetic signals with structure and consistency, then it may not be a passive object at all. It may be functioning as a processor, a system that encodes, transfers, and possibly transforms information using the physical properties of space itself. And that interpretation gains weight when we consider what happened next. Within hours of confirming the internal conduction pathways, both NASA and the European Space Agency initiated a coordinated deep space telemetry restriction. This was not a routine data management decision. It was an emergency protocol rarely used in modern astrophysics. Public data streams were limited, certain observational feeds were paused, and internal communications were shifted into restricted channels. While the agencies did not release a detailed explanation, the timing of the decision strongly suggests that the implications of the data extend beyond academic research.